Hello, this video is for textbook lesson chapter 1, lesson 6, and it's titled Subtracting Integers, where our objective is to subtract integers. And our vocabulary for this lesson is opposite and difference. So here we have earth science is our subject for this example, and Jenny. Interesting name for a volcano. Jenny is an underwater volcano in the Caribbean Sea. Eruptions have caused the volcano to grow. In 1962, the summit elevation, and by summit we mean the very peak of it, the top of the volcano, the summit elevation of Jenny was negative 235 meters, meaning that measured from the surface of the sea level, the surface of the water here, down to what was the top of the volcano in 1962, had a measurement of 235 meters. We're calling it a negative 235 meters because it is below the surface of the water level there. In 2002, the summit elevation was negative 182 meters. By how many meters did the elevation of the volcano change? Example 3, and we'll see that later on in this lesson, uses integer subtraction to answer the question. So we're going to be subtracting integers. Let's take a look at that down here on the number line. As you can see from the number line below, the expression 5 minus 4 and 5 plus negative 4 have the same value, which the answer is 1. So in our previous lesson, we were doing adding integers, right? Integers are positive and negative, like whole numbers. The whole numbers 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 forever. And integers are all the whole numbers, all those numbers I just said, and their opposites, and which kind of leads to the word opposite there. So negative 1, negative 2, negative 3, those are all integers. So that's what we did in our last lesson, was we added integers. Now we're subtracting integers, and we see here that 5 minus 4, we start at 5, subtract 4, we end up at 1. And and you've heard me say this in other lessons, if we change the sign from subtraction to addition, and then take the opposite of the number, or the opposite of the value that follows that sign that we changed, we would get negative 4. So we would end up with 5 plus negative 4, and that's the same as 5 minus 4. Now if we look over here in the reading algebra section, you can check to see the other pairs of expressions, such as 8 minus 3 and 8 plus negative 3. So they changed the sign, took the opposite of 3, which is negative 3, and these two expressions also have the same value. The process of looking at specific examples and drawing a general conclusion is called inductive reasoning. So we just take some examples, and such as the 5 minus 4 and the 5 plus negative 4, and we see that process of change the sign, take the opposite number, or the idea that 5 minus a number is the same as 5 plus that number's opposite. We could take other examples like the 8 minus 3 and changing that to 8 plus negative 3 and see, gee, that holds true as well. And if we find enough of these examples, we come to some point that we can make a conclusion that that process works, and that is known as inductive reasoning. So this is something I've been teaching my students ever since I was several years ago. My first year teaching was 6th grade. And I was teaching 6th grade math class, in which I told my students there's no such thing as subtraction. And they said, well, what do you mean there's no such thing as subtraction? We've been learning it for years. And I had to explain to them that in elementary school and lower grades, the concept of negative numbers is something that's kind of difficult to teach young children that way. So we start off with teaching you how to count, 1, 2, 3, 4, 5. Then we teach you how to add. We say 2 plus 3, you got 2 candies, and you add 3 candies. How many candies do you have? Oh, 5 candies, and we teach children to add. Then after that, we teach them to subtract. If you have 5 candies, and I take 2 candies away, how many candies do you have left? And the student says, I have 3, so we've taught you to subtract. It's not till years later that we teach students about negative numbers. So at that point, finally, we're at the point now that we can say subtraction really doesn't exist. It's just the subtraction is just another way of writing the addition of negative numbers. For instance, later on in mathematics, you'll talk about the properties of mathematics and the properties in number systems, like the commutative property of addition and the commutative property of multiplication and the distributive property of multiplication over division and possibly the associative property of addition and associative property of multiplication. It's always of addition or of multiplication. So theoretically, subtraction and division doesn't actually exist. They're just the inverse operations of other operations that we actually have properties for. So that was just a bonus. Later on, I had a student who was a member of that 6th grade math class who went on to high school in her freshman year, and her teacher said something about subtracting, in which she said, subtraction doesn't exist. She asked her, where did you hear that? And she said, my 6th grade teacher told me. And that teacher told her, if you see him again, tell him thank you. Obviously, I did see her again. So, interesting story. So we'll go ahead and we'll move on. On the next slide here, we have this. I've reposted this part here, the number line. So these equivalent expressions suggest the following rule for subtracting integers. In words, we say that to subtract an integer, you add its opposite. So that's pretty much saying what I've been saying already, right? To subtract an integer, like subtracting 7 from 3, you would add its opposite instead. So we take the subtraction, change it to addition, which is add, take the opposite of 7, which is negative 7, and 3 plus negative 7 would be negative 4. In algebra, we would say that any number a minus any number b is equal to a plus the opposite of b. So you can change the sign and then take the opposite of the value that follows the sign that you changed. Here's some examples here. We have 4 minus 10. So we're going to change the subtraction to addition, take the opposite of negative or opposite of 10 and make that negative 10. 4 plus negative 10 is negative 6. And remember a little bit of reminder on that. Negative 10 has a greater absolute value than positive 4. So the answer is going to be negative, just like the negative 10 with the greater absolute value. And then we just take the greater absolute value, subtract the lesser absolute value. So 10 minus 4 is 6. So just a little bit of reminder there how we get from this line to that line. 7 minus negative 5. Change the sign from subtraction to addition. The opposite of negative 5 is positive 5. 7 plus 5 is 12. Negative 2 minus negative 9. Once again, we're going to take the subtraction, change it to addition. The opposite of negative 9 is positive 9. Negative 2 plus 9 is 7. Here we have evaluating variable expressions in example 2. So we're going to do some evaluating again. Evaluating is where we take the given value for the variable, such as x equals negative 9, and anywhere we see an x, we're going to substitute this value of negative 9 for that x. So our first one is x minus negative 40 and 7 minus negative 9. So taking the x and substituting negative 9, we rewrite this line here. Now we're going to change the sign from subtraction to addition. Take the opposite of negative 40, which is positive 40. Negative 9 plus 40 is 31. It's going to be positive because 40 has a greater absolute value than negative 9, and 40 minus 9 is 31. On the next one here, example B, 7 minus x. So we're going to put 7 minus negative 9. And this is a strategy that I really encourage you to use as you calculate these problems. Notice that whenever you do the rewrite, whatever x is put into parentheses. And the reason that I teach this and the reason I really encourage you to do so is that you don't want these minus signs to get confused with the negative signs. It's like the parentheses holds the negative symbol in there with the 9 to help avoid any confusion. So we're going to change the subtraction to addition. The opposite of negative 9 is positive 9. 7 plus 9 is 16. So, I got a checkpoint. I thought we were going to go to example 3 where we have the volcano story again. So we're going to find the difference. Let's go with 2 minus 6. We can call that 2. Change the sign to addition. The opposite of 6 is negative 6. And then 2 plus negative 6. Well, they're different signs. Negative 6 has a greater absolute value than positive 2. So the answer is going to be negative. And since they're different, I'm actually going to subtract. 6 minus 2 is 4. So my answer would be negative 4. On number 2, question 2 here, we have 3 minus negative 8. Let's go ahead and change the subtraction to addition. The opposite of negative 8 is positive 8, and 3 plus 8 is 11. So you'll see that minus a negative is the same as plus a positive. Let's look at number 4. Negative 1 minus negative 13. And I kind of like to maybe keep that negative 1 in parentheses as well. Kind of holds that negative sign to the 1. So I end up with, or you could raise the sign. We could raise the negative symbol up here, make it up higher from the subtraction, which is a good strategy as well. Change it to addition. The opposite of negative 13 is positive 13. And they are different signs. And the 13 is positive. It has a greater absolute value than the negative 1. So it is going to be positive. You could put a little plus sign if you wanted just up there to remind you it's going to be positive. And since they are different, we'll subtract. 13 minus 1 is 12. So it's going to be positive 12. Let's do number 6 right here, 25. 25 minus y. Now, I haven't even looked up here. Well, now I am. It's negative 14. But I just rewrite it. 25 minus y, 25 minus, and then whatever y is, I create a parentheses space to hold that value in. And here's why. Why? Figuratively and literally. So the reason for it is that whenever I put that negative 14 in there, it kind of keeps this negative sign separate from the subtraction sign. So now I can do 25, change the sign to addition, and the opposite of negative 14 is positive 14. They are the same sign. They're both positive, so I'm going to add them. And I'm going to think of 14 as 10 plus 4. 25, 35, plus 4 more is 39. And then finally, let's do number 8 for practice. I have negative 9. I'll raise that negative sign so it does not get confused with the subtraction sign. Although the textbook keeps them the same level. And then whatever y is. Notice I'm using the parenthesis strategy to hold whatever y is. I just rewrote this problem right here. I just rewrote it and used parentheses for the y. Now I'm going to plug in whatever y is. Negative 14, raise that negative sign to keep it separate from subtraction. And then I got negative 9, change the sign, subtraction to addition. Opposite of negative 14 is positive 14. They are different signs. The 9 is negative, a lot of N words there. And the 14 is positive. So absolute value of 14 is greater than the absolute value of negative 9. So the answer is going to be positive. And 14 minus 9 is 5. All right, so there's all of my checkpoint questions taken care of. So let's go ahead and go on to the evaluating change in the volcano. Well, here's the volcano actually above the water level, right? I don't think it's the same one, though. So let's go ahead and read it. In the real world, Earth science. After 4 years of eruptions, an underwater volcano off the coast of Iceland broke through the ocean's surface. The eruptions began 130 meters below sea level. the volcano became the island of Surtsey with an elevation of 174 meters. What was the elevation? So we'll go ahead and let's go ahead and look at the Kick'em one first, and we'll come back to that one. To answer the question on page 34, that was the Kick'em question about the change in elevation of the volcano Kick'em. You can subtract the elevation in 1962 from the elevation in 2002. So let's write a verbal model to find the change in elevation. That is equal to the elevation in 2002 minus the elevation in 1962. So we will take the elevation in 2002, the negative 182, minus the measurement of negative 235, which was what it was in 1962. We're going to change the sign. The opposite of negative 235 is positive 235. Now the absolute value of negative 182 is less than the absolute value of 235. So our answer is going to be positive, and since they are different signs, we're actually going to subtract 182 from 235, and that would give us 53. So the difference is 53. So the summit elevation of Kick'em increased by 53 meters from 1962 to 2002. Now, it could become confusing on how to set this up. What if somebody had made a mistake and actually put the elevation in 1962, said, oh, it's the elevation in 1962 minus the elevation of 2002, right? So if we did that, let's try that. We would have, where can I squeeze it in at? We'll squeeze it in right over here. So we would end up with negative 235, and we're trying to find the difference, so we know that would be subtraction, and minus the elevation 2002, which would be negative 182. And then if we tried that, we would take negative 235. We would change the sign to addition. The opposite of 182 would be 182. And we would end up with, well, the absolute value of negative 235 is 235. The absolute value of 182 is 182. So the negative value has the greater absolute value, so our answer would be a negative number. Well, you can't have change that's going to be negative, right? We're saying how much change is there? There can't be a negative change, because this is kind of like the absolute value concept of distance can't be zero, right? And we're talking about how much did the volcano grow. Even if it was how much did it shrink, if we were talking about something shrinking, it would still be a positive distance. So whenever you set this up for a question like this, you want to get the greater value minus the lesser value. And on a number line, if we look on a number line here, and we were to plot these two, and we had negative 235, and we had negative 182. Well, we know that numbers to the right of other numbers are greater than those numbers. So on a number line, negative 182 would be greater than negative 235. So it's the greater value minus the lesser value. So if we looked at this one over here, after 4 years of eruptions of the underwater volcano, so we're looking for, it says the eruptions began 130 meters below. So this is like negative 130, right? And now it has an elevation of 174, and it's above water, so that's plus 174. So we would end up with 174, and we want to know the difference between that and negative 130. So we would take 174, change the sign. The opposite of 130, negative 130, is positive 130. And then we would add those together, and that would be 304, I believe. 304. Let's check my mental math. 174, 130, 4, 10, 1, 3. Yep, indeed it would be 304. So the important thing is on this, whenever you're trying to find the difference of something, make sure you're doing the greater value minus the lesser value. So here we have temperature changes, 32 degrees to -10. Well, 32 is the greater value, and we want to find the difference between that and -10. So we'd have 32, change the sign, opposite of -10 is +10, and that would be 42. That is number 9. Looking at number 10, -45 and -80. Well, -45 is the greater value, so -45. I'm going to find the difference between that and -80. So we end up with -45. Change the sign to addition. Take the opposite of -80, which is +80. And now they are different signs. We're adding them. They are different signs. One's positive, one's negative. The positive number has a greater absolute value than the negative number, so our answer is going to be positive, which is good because distance or change in temperature is still going to be what we're wanting the amount of change. So it's going to be always going to be a positive. It's either going up or down. It's kind of trying to think of a good way to explain that concept, but you want your value to be positive, and we'll see that in question 12. I'm kind of holding that as a surprise at the end, right? So we know our answer is going to be positive, and we need to find the difference between these, and that would be 35. So that's going to be a change of 35 degrees Fahrenheit. All right, this one here, number 12. Let's look at 12 and investigate what I've been saying about subtracting the lesser value from the greater value. So on this one here, let's think about this. If I had a thermometer and it's at -2 degrees Celsius, and here's my, not doing a very good job with the thermometer there. So let's see. Oh, let's use a straight line. All right, there we go. So here's my thermometer, and I'm at -2, and then we want to know it goes from -2 to +15. So up here is 15. Well, we know right about what here is 0, correct? So we had 2 degrees here, 15 degrees here. So our answer should be 17. Well, let's go ahead and try taking the greater value, 15, and find the difference between that and -2. And then we would have 15, change the sign to addition, opposite of -2 is +2, and sure enough we get 17. Well, what happens if we tried it the other way? What if we took -2 minus 15, right? Then we would have -2, change the sign, opposite of 15 is -15, and we would end up with, what, -17? And we don't have we see that the amount of change was not a -17, but a +17. So looking at our guided practice section, just kind of checking on it there. Write the phrase is a variable expression, the difference of -15 and a number x. So difference means subtraction. And so we're going to subtract. We're going to start with the first number listed, -15 minus x. Explain how you would find the difference of -45 and -60. Well, again, difference means subtraction, so it's -45 minus -60. Erase that sign there. And well, how would I explain it? Well, I keep that first number the same, change the sign to addition, take the opposite of -60, which is +60. And then the absolute value of 60 is greater than the absolute value of -45, so our answer is going to be positive. And then 60 minus 45 should be 15, right? Find the difference between, let's do number 4. Let's take the 6, change the sign to addition. The opposite of -2 is +2, and 6 plus 2 is 8. Let's do number 6 over here. -5. Let's change the sign to addition. The opposite of -1 is +1. And absolute value of -5 is greater than absolute value of 1. So our answer is going to be negative to match up with the one with the greater absolute value. And then we're going to subtract. 5 minus 1 is 4. So we get -4. And then I'm going to go ahead and do number 9 real quick here. We're going to evaluate, means we have to substitute. So I'm going to do 7 minus, and then I'm going to use parentheses to hold whatever m is supposed to be, and that is -6. So I end up with 7 minus -6. I'll rewrite it over here, get some room. 7, change the sign. The opposite of -6 is +6, and 7 plus 6 is 13. All right, and I think I'll go ahead and skip 11. This has got to be a pretty lengthy lesson as it is, so we'll go ahead and we'll finish off with that last question that we just did here in the guided practice. So that's everything I have for lesson 1.6, titled Subtracting Integers, where we learn to subtract integers. Remember, it's all about, we can put it into words by saying to subtract an integer, add its opposite. Or another way that we could say it is just change if you want it to be addition instead, if you'd rather work with addition, just change the sign from subtraction to addition, and then take the opposite of the number following the subtraction sign that you changed. All right, thank you.